Okay, that's better. All right, we're going to go back up here. Ready? How can you write an expression for sums such as 5 plus 10 plus 15 plus 50? We're going to kind of learn that today. Sequence and series are two things we're going to talk about. A sequence is a function whose domain is a set of consecutive integers. What does consecutive mean? One right after another. If the domain is not specified, it's understood that it starts with 1. So for most of what you're going to be working with, your domain is just going to be 1, 2, 3, 4, 5, so on. Okay? For this whole section. Unless they tell you to start otherwise, which I will show you when that happens. The terms of the sequence are the output, the values in the range, or the output. Okay? You might want to think of it as the output. They are specified usually as A of n. The input, or this is always going to be just n. Let's just say that as n. That's going to be n. So these are going to be your input numbers represented with n most of the time, and your output's going to be A of n, and I'll show you that in a second. Okay. The expression formed when the terms of a sequence are added together, so there's two different things we're doing. We're doing sequences and series, two different things. We're going to start with sequences, but we'll see series in a minute. It's the expression formed when the terms of a sequence are added together. It could be finite or infinite. Infinite. What do you think the difference is between these two? Finite. Yeah, these stop and these go forever. It's represented usually with infinity. It just kind of means it goes forever. Summation notation. Notation for a series that uses the uppercase Greek letter, that thing, stands for summation. It's called sigma. You might also see it as sigma notation. Okay? All right. So, first of all, let's write the first 5 terms of this sequence right here. So, A of n is the output, n is the input. The terms are the output. So I want to know what the first 5 output A of n's would be. And what did I say? If they don't tell you what the domain or input is, what do you use? 1, 2, 3, 4, 5. So that means we're going to, and this is output. I'm going to write this here. A of n. The input, if we have to do the first 5, is going to be 1, 2, 3, 4, and 5. So we're going to plug that in for n and find out what A of n would be. It's pretty easy. I'll just tell you. It's 4, 9, 14, 19, and 24. Does everybody know how I did that, or where those numbers came from? Please be honest. I just took 1 and plugged it in, that gave me 4. Took 2 and plugged it in, that gave me 9. Okay? All right, same thing for here. If the input is 1, 2, 3, 4, 5, because the first 5 terms, I need the first 5 output numbers. With those as input, I would get -1. 2 to the 1 minus 3 would be -1. 2 to the 2 minus 3 would be 1, and so on. I'm going to keep going here. Just to be sure, I'm going to write this out. 2 to the 2 minus 3 equals 1, and so on. So for clarity, I just want to write up here because, of course, it's going to get better than this. This is n, and this is A of n. Okay? My little exponents are my n's, my input. The output is my A of n. Can you see that? Okay. All right. That's the first thing you'll have to do on your homework. Second thing says describe the pattern. That's one thing I have to do. Write the next term, which is A of n, or output. And write a rule for the nth term of the sequence. Remember, n represents the domain number. A of n represents any, oops, supposed to be term, sorry, term or output. Okay, so are they giving me the output or the input here? giving me the output. Okay? Write the next term. Term is the output. So this is A of n. I'm going to have to find out what the next number is when you look like that. And sometimes you can just look at it. What do you think's happening to this? You're taking away 4 every time, right? Okay. So if you remember, my input is 1, 2, 3, 4, 5, right? So this is an easy one, but this is how I start out figuring out what it is. I'm going to list my n's. 1, 2, 3, 4, 5. I'm going to list my a of n's that they gave me. So I got to do something to 1 to get negative 4. I got to do something to 2 to get negative 8, and so on. Okay, so what do I have to do to 1 to get negative 4? Multiply by what? Does that work for this one? 2 times negative 4? 3 times negative 4? Yes. So I'm going to write that down. It's going to work all the way down for me. That's perfect. So this is how I'm going to write it down here. This column represents my n. I'm multiplying every n by negative 4. And it equals my a of n. Oh, would you look at that? We came up with a function. Okay? So in words, describe the pattern in words. I'm just going to write n times negative 4. Good enough. That's the pattern. To the next term, if I went up to n equals 6, what would I have? 6 times negative 4, I would have negative 24. And then the third one says write the function. Now the appropriate way to write this function, usually you'll see it with a of n on the outside, just like you used to see y equals mx plus b, y is always first. Same thing here. Equals negative 4n. And there's the rule. That's the third thing I had to do. Okay? So, let's do another one. This is kind of what you're going to have to do today. You're going to be given a set of terms, and you're going to have to come up with the function. Sometimes it's harder than others. Again, just look at it as a challenge. Again, remember, don't fret over it. Because in 12.2 and 12.3, I'm going to give you a formula, but you have to, every teacher I talk to said they have to play with it a little bit. So, let's do another one. Okay, same thing. I'm going to just write out some n's here. 1, 2, 3, 4. They gave me 4 terms, so I'm just going to write 1, 2, 3, 4. That's my input. My a of n is 7, 11, 15, and 19. So, step back and look at it and say, it's not always simple multiply. It could be multiply and add. It could be squaring. It could be dividing. It could be something. So kind of let's look at this. What can you do to go from 1 to 7? What's something? Multiply by 7. Does that work here? No. The other thing that helps sometimes, if you look at this, is there a straight difference between these two? What is it? 4. So our thing might involve 4 somehow. So what else? Somebody else have another idea? Just throw some ideas out. It's like a puzzle. It's a challenge. Oh, Claire is saying if I do 1 times 4 plus 3, I get 7, correct? 2 times 4 plus 3, I get 11. She's onto something. Let's write that out. If I do 1 times 4 plus 3, it works for that one. 2 times 4 plus 3. It's going to work for me. Right on. So I'm going to translate that to using n and a of n. So this is my n column times 4 plus 3 equals a of n. I could multiply anything. I could stick any n in there and get the next number, or get that term that goes with that input. All right, so number 1, in words, I would say n times 4 plus 3. The next term would be plugging in 5. What would I get? 23. 5 times 4 plus 3 would be 23. And then number 3 is my function written correctly would look like this. Again, for some people it comes easier than others. You'll get it. I thought it was kind of fun actually when I was playing with it. Let's do a couple more. Okay, so again, I'm going to write down my n's. 1, 2, 3, 4. My a of n's equal 2, 5, 10, and 17. So always look at this. I want to say always, but most of the time. This goes from 2 to 5, which is a difference of what? 3, and then a difference of what? 5, and then a difference of 7, right? Usually when something like that happens, there's usually an exponent involved. So let's see if we can figure out. How can you go from 1 to 2? That would also work from 2 to 5. See, you're smarter than me. Look at that. No, I got it. It took me a little longer, but I got it. See, very good. So if you write this, 1 squared plus 1, that gives me 2. 2 squared plus 1 gives me 5. It's going to work all the way down. 3 squared plus 1, 4 squared plus 1. So I'm going to write that now substituting with n and a of n. N squared plus 1 equals a of n. Okay? We won't do the 1, 2, and 3. We'll just write the function correctly here. A of n equals n squared plus 1. Oh, you can do it with fractions too. Okay? So I'm going to write 1, 2, 3, 4. I have 4 terms, and they equal 2 over 3, 2 over 9, 2 over 27, and 2 over 81. Okay. What's consistent in the numerator? 2. So 2 is going to be part of my answer. I know that. 2 is going to be in every single one. So 2 is in my numerator. Oh, look at the what's happening to the denominators. What do you think?
Is it like 3 squared?
Not 3 squared. Somebody know? Give it a wild guess. Eunice, what do you think? She looks like she knows. No? Kelsey, what do you think? 3. Okay. 2. She's saying this. So what if I do this? I put the 3 down here, and I put the 1 as the exponent. And then this one, it's kind of tight, I know. I put the 3 down here again, and I put the 2 as the exponent from here. Ah, very good. 2 over 3 to the 3rd, and so on. So if I come up here, it's going to look like this. 2 over 3 to the n, because that number is my n, equals a of n. She is correct. Can you see them here? These are my n's right here. These are my n's. I don't know how to do that, but something like that. Those are my n's. Okay? So you get to have some fun with that today. All right. So this is sequences. Now let's talk about series. Write the series using summation notation. Yeah, Kelsey.
Oh, no. Sorry.
Okay. So I kind of pulled this image off the internet because I kind of liked it. Here's that sigma thing. It represents summation. It means you're summing up something. The thing on top represents the last value of n, okay, which is our input. The index of summation is the first value of n. Now, sometimes, like in the book, this n could be any letter. So here it happens to be n, which I like, but it could be any letter. And don't let that confuse you, just like the variable can be any letter. In the book, it's I. They use I in the book for their representation. It doesn't matter. All right, and then this represents the function. So let's look at how many terms do we have here? we were given 1, 2, 3, and 4. We're not sure what term that is. Okay? But let's see if we can figure out what the function is from going from 1 to 1, 2 to 8, 3 to 27, 4 to 64. Does anybody see what's happening? They're being cubed, aren't they? N is being cubed. This is my n. N is being cubed. So I'm going to write n cubed over here. And this is telling me that it stops at 729. So which term would have a cube of 729? Does anybody know? 9. Yes, 9. Okay? So then let's write this. Write your pretty E thingy. Okay? On the bottom is the index of summation. Where do our n values start at? 1. N equals 1. Where do our n values end at? Yeah, they do. They end at here. 9. They end at 9. Okay? And then what's our function that we came up with? N cubed. Now, remember, just don't be confused. If you want to, you could rewrite this with an I, which is probably what they have in the book, and it would look like this. That's the same thing. They're equal. Same thing. Okay? All right, let's do another one. Pardon me? Okay, what's happening here? First of all, does this one end? No. So for terminology's sake, I want to put down here that this is a finite one, and this is going to be an infinite one. Okay, first of all, we have to figure out what's happening. What's our pattern? Remember, our n is 1, 2, 3, 4, and it keeps going. I'm going to write down 1, 2, 3, 4. I'm going to help me. This helps me figure it out. This equals 1. This equals 1 over 2. This equals 1 over 4. This equals 1 over 8. Do they all have a 1 on top? They really do. They all have a 1 on top. What's happening to the bottom? This is kind of hard. Here there was an ending number, here there was not. And then we just write our function. 1 over 2 to the k minus 1. Okie dokie? All right, find the sum of the series. Let's analyze this. It's saying our input starts at 3, and then we're ending our input at 5. So what we do is we take k, we're going to do it for 3, 4, and 5. That's what that's telling me right here. It starts at 3, ends at 5. So we're going to have to plug in 3, 4, and 5. And what does sum stand for? Adding. So we take and we do 3 times 3 squared minus 7, and we add to it 3 times, oh, excuse me, I didn't write that right. I did not write that right. Let's write that over. 3 times 3 squared minus 7. I put the first input in. I'm putting 3 in. And then I add to it 3 times 4 squared minus 7. And then I add to it 3 times 5 squared minus 7. So remember, this is telling me the starting number of my n's or k's or whatever, and that's the last of the input. So you start with 3 and you go 4 and you go 5. And then you do that math and you get 20 plus 41 plus 68, which is 129. So how many numbers are we going to put in here? Starting at 1 and doing 1, 2, 3, 4, 5, ending at 5. So we're going to input 1, 2, 3, 4, and 5. Okay? And you get 8 times 1, which is 8, plus 8 times 2, which is 16, plus 24, plus 32, plus 40, which is 120. Okay, this one right here, If you get the right answer, you can have a piece of candy. I'm going to let you do it on your own.
So good.
Okay.